is Monday, February 22nd, 7SP3. I can use mean and mean absolute deviation to compare data with 60% masculine. You may or may not have remembered MAD from last year. Don't check our email. All right, vocabulary. Like I stated, that you may or may not have forgotten. Measure of center. Measure of center describes data by identifying a central point. That's your mean and your median. You remember mean and median? Yes. All right, mean is the average of the values, meaning we add them all up and divide by the total. That's something we should recall from about 5th grade. Median is that middle value. That's where we have to put them in order from least to greatest and find that middle number. We got 2 in the middle. We need to divide to find the mean of those 2. All right, measure of variability represents how the data is dispersed, or in other words, spread. That's where we have the range, interquartile range, and then mean absolute deviation. What's the range? Anybody remember? Good job. Highest and lowest, subtract the 2. Interquartile range is where we find the median of both halves and then subtract. And then mean absolute deviation. Mean absolute deviation describes the average distance between the data values in the distribution and the mean of the distribution. Or in other words, how close are the points to each other? That's what MAD tells us. How close are they together? To find the MAD, we do 3 things. We first have to find the mean. We then have to make a new list with how far each value is from the mean. And then, of course, we need to find the mean of the new list. If you need anything, it's most likely these 3 steps to MAD, how we find MAD. Go ahead and get that down real quick if you need it. Y'all feel like you don't, be my guest. But that is what we're going to be practicing today, how to find the MAD. So we need the mean. We're going to make us a new list, and then we're going to find the mean of the new list. Any questions about that? All right. Your practice is in its normal spot. School G, fold the February 22nd through 26th. If you haven't already got there, go ahead and get there. Give you a few minutes to get there. All right, everybody made it to today's practice. It is a PDF, unlike your normal practice, but it should allow you to open with Cami. Remember, Cami have those drawing tools that you can draw with it as well as type with it. As long as you're able to give me your thorough answer, it's fine with me. My approach, I like to take a picture of it and snip it and send it. But whichever is your choice, some of you type it in there. All right, so number 1 reads, the members of 2 different swim clubs swam laps on Saturday. The dot plot shows the number of laps each club member completed. It says calculate the mean number of laps and the mean absolute deviation for each swim club. The easiest will be to find the mean first. How do we find the mean? All right, when I talk mean with dot plots, I always did 1 row at a time. 40 times 3 will give us. Good job. 45 times 2. 90. I see we got 150. 55 times 2. 60 times 2. Good job. And then I will add all those up. Check that. You missing that 50. Seem like. All you have quite a bit. Check it in. Missing 120. And how many total dots do we have? All right, 49 divided by 10 will give us. Good job, 49. Now I'm gonna change the blue. Looking at swim B. We got 120, 25 times 3, or 3/4. 3/4. All right, let me get a heart attack. I said 3/4. One person said 75. 25. All right, we got a 30, 35 times 3. Oh, y'all probably trying to type this through. Check that. That seems about right. 40 times 2. All right, add it all up. All right. How many total dots? All right. So that will give us what? Good job. All right, now we need to find the MAD of the two. The first step told us to find the mean. We done already found the mean. Now we need to ask ourselves, how far are each of these points from the mean? We'll start at A. So the mean was 49. How far is 40 from 49? Times 40. So I will have 9 3 times. All right, 45 from 49. 4. So we have that twice. 50 from 49. 55 from 49. Got this twice. 60 from 49. Good, and we got that twice. So now add all those up. Bring it here. See if that will work. All right, you said 70. How many? We already said we had 10 dots. So then 70 divided by 10 will give us what? Good job. All right, so then we'll do the same with B. MA, the mean was 31. How far is 20 from 31? How far is 25 from 31? All right, we got that 3 times. How far is 30 from 31? 35 from 31. 4. All right, we got that 3 times. All right, 40 from 31. All right, we'll have that twice. 60. Somebody else got 60? All right, so 60 is verified. We know we got 10 numbers. Any questions about it? All right, y'all still need something?
Yes, ma'am. I still need something.
All right, William, let me know when you finish. You got it, William?
Almost. I'm just getting the last few numbers.
Okay, okay.
I'm done.
You know how to take a screenshot, William?
No, I don't.
Press the control key and look above the 6. You will see like a little camera-like symbol. Press that and see if it takes a snip for you.
Okay.
So anytime you logging in Zoom and I'm ready to move and you still right, just take a snip of it and then you can just go back later and finish it.
Okay.
It's supposed to give you like a little pop-up, don't it? Yeah, it'll give you a pop-up on the side and then click. But it'll go in your files. Anytime you click files to upload something, you see all your screenshots. All right, we're gonna look at question 2. It reads, the coach collected data for the same group of runners for 2 weeks. The mean distance for week 1 is 14.5 miles and the MAD was 1.15. The mean distance for week 2 is 16 miles and the MAD is 105. They want us to use this word bank to fill in some numbers. They say week 2 data values tend to be blank, their mean week 1. So let's look at it. We got the means, and then we have the MAD. Which set of numbers would you say is closer together? Two separate weeks. All right, 14.5 went with week 1. That's the mean. And then the mean of week 2 was 16. But look at this MAD. 1.15, 1.5. What that tell us? Which one is smaller?
1.15.
I about to say, let me line up at a decimal so we can see. So in other words, that'd be like 15 and 50. So that means week one is smaller. So that means with that being a smaller MAD, the numbers in week one are closer together because the MAD is smaller. And I'm gonna put that up here. That's what the MAD tells us, how close the numbers are together. So an MAD in week one is 1.15. So that's telling me week one data, they are closer together than that week two data. So then at the bottom, they asking us about week two. It says week two data values tend to be blank than their mean than week one. Closer together or farther apart? So they are farther from their mean than the week one data values are to their mean because week two has a greater what? What were we comparing? The what? That wasn't the mean. Good job. We compared the mean absolute deviation, MAD. Any questions about it? So if they ever ask you which one have values that are closer together or farther apart, make sure we look at that MAD to help us to determine it. All right, everybody got those two little blanks? All right, question number 3. If the data set described below were plotted on dot plots, which pair of data sets would show the most visual overlap? What's an overlap? Done twice. So if we're talking about dot plots, that may mean that my dot plots are pretty much got the same value. So then we're going to say. All right, so each one gave us numbers or data sets that got the same mean, but then they gave us different MADs. And remember, those MADs tell us how close they are together. So that will pretty much let us know if they'll be overlapping, how close they are together. So looking at these MADs, which data set would you say is overlapping or will have some of the same numbers? Data set from which one? A, B, C, or D? You said 2. Why you say A? All right, let me give you a visual with it. That's like saying the mean is 40. So I got some values at 40. That MAD tell me how far I am apart. So that means I'm about 8 units apart. So I got some over here at 32. And then I may have something over here at 48. That first data set, however, I would have something at 40. And then they're only 4 apart. So that'll be what? 36, 32, 44, 48. Is that a better visual of what I mean? Now, some of these will overlap because 4 and 8 are multiples of each other. But which one would give us the most? Most numbers that'll be overlapping. Look at your MAD. Look at your MAD. Are any of them close to each other, MADs? 5 and 6. I mean, if I start at 30, then I'm gonna possibly have some over here at 25, but then I'm gonna also have some at 24 because the other data set had them 6 units apart. B would be the correct answer due to those MADs. So if the 2 MADs are very close together, the numbers will overlap. All right, y'all got it? Who that with me? Who I'm still echoing on? That's you? Get you some headphones. Or cut it all the way down. All right, we're gonna try to make it through 4. It says Sarah was curious about how many text messages students with cell phones send each day. She surveyed a random sample of students who own cell phones at the middle school and another at the high school. For the middle school, the mean number of texts was 60. At the high school, the mean number was 76. They said the MADs were the same. How does the difference of the means compare to the mean absolute deviation? How does the difference of the means compare to the mean absolute deviation? What would be the difference of the mean? What's the difference? How do I find it? Difference. Good job. So subtract these means. So then 76 minus 60 will give us what? 16. What does that tell us about these data sets, Mercedes? One had a mean of 76, one had a mean of 60, and the difference was 16. Are they close together? No, far. Now this isn't the MAD, Joseph. This is just the average. It's like saying I did an average of my 7th graders, you all was 60, my 8th graders was 76, and then I subtracted the 2 and I got 60. What does that tell us about these two data sets? Let me reword it. Who texts the most? How you know? Because their mean is 76 and the mean of middle school is 60. Good job. So that's one thing we know. The high schoolers text more, but what does this MAD tell us? Both of them have an MAD of 5. What do we say MAD tell us? How close are they? So if the high school had a mean of 76 and an MAD of 5, are those numbers far apart? Not really. So that means most of those values are going to be around 70, 71, somewhere in that number. But then I got these middle school that says 60 and the MAD is 5. So what kind of numbers would my middle schools have each day? 60, 61, about 65 maybe. And then I may get 55, 58, somewhere in there. What's the difference between those sets of numbers? What does all that data show us or tell us? You done already said it, now I'm just rewording it. What did you tell me about the means earlier? High school students text more each month. How you know that? They had a higher mean and the data was close together. Compared to the middle school, having values only around 60. So it's just showing us how we can use the data they give us to help us rationalize about information. Any questions about it? See y'all typing. Get your hood, come on. I imagine that's what she's talking to her about. All right, y'all got it? Oh, we still tight. Still tight. Let me know. I don't see the big deal about to do this. Tell us to take it down, take it down. Tyler, she was talking to you too. Get your hood down. She probably trying to sit there and wonder who you are. I don't see the big deal, but like I tell them all, I'm a respectful person. If somebody asked me to do it, I'm just politely do it. Because sometimes I like to keep my little hood on. I don't know the name of it. You got this. See the type. You got it. The rest of it, you got it? All right, number 5 said the mean absolute deviation is best described as what? We found the MAD earlier. What did we do to get that MAD? Did we add the values and then divide by the number of values? Did we find the average and then between them and then find the mean? Did we find the difference between the mean? Or did we approximate? Meaning, did we estimate? What would you say is the MAD? Now, earlier I told you to write down 3 steps on how we find the MAD. Anybody got them 3 steps? Find the mean. So that's finding the what? The average. You gave us keyword. So what's our answer? Think about what you just said. Average of the values. What else? What's our other steps? You make a new list. But before I make that new list, I gotta ask myself. Go down. You missed something. So I find my mean, and then I gotta ask myself something. Before I can make that new list, I'm asking myself as I'm making it. Not exactly how close or far apart, but how close they are to the what? To the mean. So which one would you think? Did we estimate? Did we find the MAD each time by estimate? Oh, I'm gonna say the MAD just 3. Is that what we did? No. Okay. Did we find the MAD by finding the difference, subtracting the mean? Did that give us MAD? Did 76 minus 60 give me the MAD of 5? No. Okay, so clearly that's not it. So look at A and be careful. A says I add all the values and I divide by the number of values. That's the mean. And then Xavier said, okay, if that's the mean, then okay, our answer got to be B. Good. Process of elimination. Any questions about it? All right, we're going to try to make it through one more, if we can. We're about to stretch this time. Let's see if we got time. Let me make it smaller. All right, it said the average winter temperature in 45 states were recorded and divided by a geometric region. Choose true or false for each statement. Data in 45 states. All right, A says the mean of region 2 is 5.8 greater than the mean of region 1. Before I can answer that, what do I need to do? Let's find the mean. Let's look at region 1. We got 31. Somebody do 32 times 3. All right, 33 times 3. 35 times 4. You said 140? Okay. got a 36. All right, add it all up. All right, somebody check for us. All right, I got 374, 402. I need somebody else.
402.
All right. How many total dots do we have? All right, divide 402 by 15.
46.
Check that. 402 divided by 15. 3, check that. All right, let's try region 2. I see we got a 36. We got a 37. Somebody do 38 times 2. All right, 39 times 3. 40 times 4. 41 times 3. And we got a 42. All right, that's verification. How many total dots? 15. Divide it out.
39.4.
Yes, sir. All right, they said the mean of region 2 is blank greater. So would you say 39 is 5.8 more than 36? What's 26 plus 5?
31.
Is 31 close to 39? No. So I'm gonna say that's false. All right, B said the data of region 2 greater variability than the data in region 3 because the data are clustered around a greater average temperature. Okay, so right. Yeah, I gotta put it around the corner. Man, you want to try to stop? They said because the data are clustered around a greater average temperature. Region 2 has greater variability than region 3. Which has more variety of numbers? 2 or 3? Why you say 3?
Because they have more dots.
No, they all got 15 dots.
They're more across than separate.
What you mean by more across?
They're more equal out than the other one. Because region 1 dots is on the left side.
Oh, we on 2 and 3.
I know until region 3 is like in the middle. But it's fine.
But that ain't telling us variability. Remember, variability tells us the spread. Or in other words, your range. Where I start and where I finish.
He started at 32 and he ended at 40.
So that's about how many numbers? Look at region 2.
He started at 36 and ended at 42.
About how many numbers?
4.
4. So that means does region 2 have a greater variability?
No.
Because all them numbers right there closer together. All right, C said the difference of the means of region 2 and 3. I'm going to let you figure that out. And then D said the average of the means. You got to figure that part out too, but at least you made it through A and B. As always, I will post this recording. It'll be after, of course, buses leave, so that'll be about 2 o'clock. You may have a few more questions you need to answer after I complete it. Y'all know my motto: if I choose not to go back and complete it, at least submit what we did to get a grade. Some of you haven't submitted nothing. I don't know if you think grades play this year or what, but we gotta get it together. Those of you at home, have a good one. See you later.
See you later, Miss Kathy.
Have a good day.
Y'all too.